This video is for the lesson 5.7 homework, but again, it's standard form, okay? So number one, what is the name of lines that lie upon each other in such a way that when we look at them, they appear to be a single line? So this is when we have two lines, it's the same line. When we have infinite solutions, those lines are called coinciding lines. It's more of a fun fact than a vocab word. So when it's the same line, they're sitting on top of each other, it's called coinciding lines. So number two, what is the name of lines in the same plane that never intersect? Parallel. Parallel. All right, what makes these tougher is the fact that you do have to put them in slope-intercept form. Okay? That is the only way to know where to shade. So when they're in standard form, they have to be in slope-intercept form. All right, number three starts us off with a special case. X is less than 3. So if y equal lines, if it's y equals or even greater than, less than, that line is always going to be horizontal. If it starts with X, which direction is that line going to go? Vertical. So where X is 3, so this time it is the X-intercept, it is the X-axis. So at that 3, we're going to put a vertical line. And it's dashed because, look, there's no line underneath there. Okay. Now, it says X is less than. Would less than be to the left or to the right of this line? Left or right, which would be less than this line? Left. So just like we did yesterday. Okay. So we have got to put this equation in slope-intercept form. 4x plus 3y is less than 9. Okay, slope-intercept, I need y by itself. So, what do I do first to get y by itself? Move the 4x, get the x completely off that side. So now I've got 3y. So remember, x goes first, negative 4x plus 9. All right, how do I get this 3 away from this y? Everything gets divided by 3. Okay, negative 4 over 3. Remember, simplify all your fractions in your calculator. Just type them in and see if they simplify. If it stays the same, then that's what it is. And then 9 over 3 is a 3. All right, that is my line. So I can put a dot at positive 3. That's the y-intercept. So on the y-axis, I'm going to put a dot at positive 3. Okay. Now this time I have to do it by slope. So my slope is negative 4 over 3. So I'm going to go down 4 over 3. So from this point, 1, 2, wait. Let's count a little bit better. 1, 2, 3, 4. And then 1, 2, 3. Now that one, we look at our sign, is solid. So I'm going to connect that one with a solid. Okay. And then y is less than. So find the y-intercept. All the y's that are less than, so that's below this line. And so where I start getting those boxes, woo, that's where I shade. Okay. I know it's a lot. Okay, number 4. Now, number 4, since they're both regular old lines, I can do the menu 3-2 on this one. So remember, if it just wants a solution, especially if it's equations, you can put standard form. Now, it's not going to do everything for me, but it's at least going to give me the point where they cross. 2x plus y equals 3. So these lines are going to cross. Ooh, no solution found. What's that mean the lines are going to look like? If this is no solution. So I know my lines are never going to touch. They're going to be parallel. All right, so let's convert them. So 2x plus y greater than negative 1. I need y by itself. What do? Subtract 2x, subtract 2x. Y is greater than negative 2x minus 1. Okay, so there's one down. And then the other one, 2x plus y is greater than or equal to 3. So do the same thing, right? Negative 2x minus 2x. Y is greater than or equal to negative 2x plus 3. Okay, so negative 2x minus 1. That means I'm going to have a dot at negative 1. The slope, negative 2. If the slope is negative 2, remember what I told you? If it was a whole number, not a fraction, put it over 1. So you're going to go down 2 over 1. So from this dot, 1, 2 over 1. And then I look at the sign. There's no line underneath it, so this sign, or this line, is going to be dashed. All right, and y is greater than. So greater than, find the y-intercept. Greater than the y-intercept, so above that line. So everything up here. All right, and my other line, negative 2x plus 3. Plus 3 tells me that's my y-intercept. The slope is the same. Down 2 over 1. Down 2 over 1. And then that one is a solid line. And then y is greater than or equal to, so find the y-intercept, greater than the y-intercept. So if this had been a system of equations, no solution, they never cross. But since it's a system of inequalities, it does have a solution. Everything above that pink line, because everything above the blue line is a solution to the blue line, which means the pink line is a solution to the blue line. Okay. And then let's do, trying to find some different ones here. Let's do number 6. 5 is another one that's parallel, so I don't think we need to practice that one. All right, number 6. X plus 2y greater than or equal to 4. Well, this one is one that I can do the menu 3-2 on. X plus 2y, remember, change it to an equals 4. X minus y equals 1. So my good point here, 2, 1. That point is going to work for both lines. So at 2, 1, I know both lines are going to go through that point. Okay, y by itself. What do I got to do to get y by itself? Do what? Don't divide x. Subtract it. Negative x plus 4, okay? What's the last thing? To get y by itself. Everything gets divided by 2. Okay. So some refreshers here. Negative x over 2. There's an invisible 1 here. So I'm going to pull the 1/2 out and tack the x on. 4 over 2, if you type that in your calculator, simplifies to 2. All right, next equation. X minus y is greater than or equal to 1. I need to get x by itself. How do I get x by itself? What have we done every single time to move x? We've subtracted it. So that's your first step pretty much every time in standard form. Subtract the x from both sides. So this cancels. Now, is the y by itself? It can't be negative. So how do we get rid of that negative? Everybody flips. Now, remember with inequalities. So technically what you're doing is you're dividing everything by -1. If you divide by a negative, your inequality sign flips. And you bet your bottom dollar that's the question. They're going to put one on there. That makes you do that, hoping you forget that rule. So the y becomes positive, the negative x becomes positive, the positive 1 becomes negative. All right, here we go. Plus 2 is my y-intercept. So, try to get everything to fit here. I can put a dot at the 2, and then I've got that good green dot. And then it's going to have a line underneath it. Or it's going to be a solid line because it's got a line underneath it. And then y is less than. So I go to the y-intercept. Everything less than that. So below the line. And then the other one, the y-intercept is -1. So I go to -1. That little green dot, that's my good line. This line is going to be solid as well. And then y is less than. So less than the y-intercept. Everything below this line. So where they cross, which is this section here, that's your solution. All right, here's the good news. Put your name on it, turn it in the box. If you want to practice some more, you're more than welcome to. But as long as you have these questions answered, you are good for the day. Okay, these are the toughest questions in this unit. These are the hard ones.